Hello everyone. In this video we are going to look at how to utilize Jamovi to help us answer some basic normal distribution questions. Okay, our scenario is as follows. Harry has been studying the athletic performance of top XFIT athletes. He knows that the winners of the XFIT games can clean N 202 pounds, 729 pounds squared. Note cleans are a type of lift. Harry has been following a particularly promising athlete, Jack, who can clean 248 pounds. Provide answers to 3 decimal places. Okay, so we're given a little bit of information, and we also are going to be able to extract some more detailed parts about our normal distribution in just a second. So our first question is, what percent of XFIT competitors can clean more than Jack? Okay, so before we do anything, we're going to utilize a new tool. We're going to utilize this R editor. So we're going to do RJ editor. We're going to click on this little gear, and we're going to change this to show code and output. Okay, do not fear, this is not a programming class, but we are going to learn just a few small things that we can do, mostly to help us with some of the other things we have. So what I'm going to put in here is we can just say that mu equals the true mean of these cleans that the CrossFitters can do is given to us in this N statement. So the first thing is given is the true mean pounds that they can clean. So that's mu, and that is 202. All right, I'm just going to hit enter, and then I'm also going to put in the variance, var. And I know what that is because it's given to me right next to it. It's this 729 pounds squared. So I'm just going to copy that, paste it in. And then I'm just going to say that the standard deviation, SD, is equal to the square root of var. Okay, now I can either hit this play or I can hit Control-Shift-Enter to run. And when I run it, it's going to pop up over here. And if I also want to just grab the standard deviation, let's run that as well. Control-Shift-Enter. And it pulls out all of these values for me. So I know what the mu is, I know what the variance is, and I know what the standard deviation is, and I was able to extract all that information. Now, I also know that x equals, or our observation of what Jack was able to do, is 248. All right, it's handy to just keep this information organized so that we can see it very quickly in just a second. Okay, so now what we can do is we're going to try to figure out what percent of CrossFit competitors can clean more than Jack. All right, so let's go to distraction, and this is going to let us use the normal distribution, and we're allowed to use this normal distribution because it says N. That represents that this distribution is in fact normal. Let's go ahead and click on it, and now it's going to ask us for what the mean is. Now, the reason why we did all of this up here is just so that we had it quickly at our access. We know that the mean is 202, and we know that the standard deviation is 27. And then we just need to compute our probability. Okay, so from here, we need to just put in our probability is going to be 248, and we can hit enter. Now, we're given this shaded area, so this is the probability that a randomly selected person, right, can clean. This is less than what Jack does. But the question was, what percent of XFIT competitors can clean more than Jack? Okay, so if we look over here, we can see this probability of X is less than or equal to X1, and we want it to be greater than or equal to X1. And we get this answer of 0.044. And we look over here, and it's 0.044. So very easily we can look and we can visually see how this question is being answered. All right, let's go look at the next question. Harry also knows that just being able to have a massive clean is not a perfect indicator that contestants will do well at the games. In fact, winners have had a clean weight between 177 and 242 pounds. What percent of XFIT athletes are within the optimal zone for clean weights? Okay, so let's use this compute probability again. And what we can do is type 177, and then come down here and do 242. And if we say between x1 and x2, we're given this shaded area, and we have 0.754, 75.4% of athletes can do between these two weights. Okay, last one. So Harry knows that athletes at the bottom 10% of the clean weight are not able to compete at the national championships. What is the minimum clean able to enter into the national championships? Okay, so that is a quantile question. We're just going to go over here and click on compute quantiles. And we are going to do not 0.5, but we're going to do 0.1. And let's go ahead and hit enter on that guy. Okay, in the quantiles, we want the cumulative quantile. And the cumulative quantile that we are given is that the bottom 10% is 167 pounds. So the minimum that you need to clean weight in order to be able to enter this competition is 167. So that was the cumulative quantile, and it always starts from the left side and gives you this blue line, tells you where you're at. Now, if you do the central interval quantiles, this tells you where like the middle 10% is, or the middle 20% if we were to change this quantile. And it'll give you the bounds for where that quantile is residing. But anyhow, that's how we can use Jamovi and this distraction and a little bit of the R editor to help us out in determining these normal distribution questions. Best of luck on your individual projects.